I'm Molly Adams, and this is Physics 2212 Lab 2, Line of Charge. So the purpose of this lab is to create a computational model of the tapes used in the last lab, but now instead of a point charge, they're going to be represented as a line of charge. So the model is essentially the same as the last lab with two pieces of tape on top of each other that are charged, except now they are both representative as a line of charge instead of having a point charge. So it's going to be represented as a line of equal segments, and then each of those segments has an identical point charge, so a line of charges. And all of the assumptions are the same, but now that the charge of tape is equally distributed along the length of tape instead of just located at the center as a point charge. So we're going to use the same physics principles with Coulomb's law and Newton's second law, as well as gravitational force to find the electric force, but now we're also going to be using superposition as we are calculating the net charge of multiple different charges. Additionally, the procedure is the same when we are observing the movement of the two charged tapes, but now we are going to be using a different computational model to determine the charge of the tape represented as a line. So these are our data and calculations. We have the calculations from the previous lab determining the gravitational force as well as the charge of the tape represented as a point charge. But now additionally, we have the charge of the tape represented as a line charge. And this was found by using the line of charge formula and solving for Q, which is our unknown. And then we solve for Q there to be 2.36 times 10 to the negative 8 coulombs. This is our code from the previous lab, which we're going to use to compare with the charge of the tape represented as a point charge, and see that they are different, as this one is represented as a line of point charges instead of just a single point charge. So we used a code to represent the tape as a line of 10 point charges, and those are shown there, which each having their own field. And then the results are additionally shown there from the magnitude that was calculated. So this is a breakdown of the code. We used the same constants and added our new constant that we just calculated for, and we put them in there. So then we wrote some functions. We wrote run for the electric field of the line charge, and then we represented the top and bottom tapes as additional lines of charges. And then another function is written for the electric force of the segments of the 10 segments of the bottom tape. And that's the force of the bottom tape on the top tape. And then another function is written for a vector to show the net electric force as well as the gravitational force. So some comparisons and error between our lab and this lab and the previous lab. The computational model can be considered to be more accurate as it's using a line of charge rather than a point charge. A line of charge is better representative of the model of the tape. However, it's still only a finite number of segments that we use, so it potentially could be more accurate if we use a integral rather than just the sum of the 10. And then this model does assume that the charge of tapes is actually equal, similar to the previous lab. However, the charge of the tapes could have had a different charge due to handling or different methods in the charge, so there could have been error there. And then the charge also could have not been equally distributed, so different segments could potentially have different charges, but we assumed that they were equally distributed. And then there could have been other forces acting on the tapes. And then our discussion, if we had modeled our tapes as a single point charge, we can estimate the value of the charge and compare those two between the previous lab and our lab. So we can see that the two values that we got are pretty different, showing that there's likely a difference in accuracy of the two different models, and we can assume that the line of charge is more accurate. So, and then these differ because they are represented by different models. So we have one model being a point charge, and then one model being a line of charge. The line of charge uses superposition, which usually results in a more accurate result. And we can assume that the model of the line of charge is better representative of the charge of the tapes. So we can conclude that the line of charges model is more accurate because the series of segments shows a better distribution of charge rather than just the point charge. And then we can conclude that breaking something into segments allows you to get increasingly more accurate, and that computational models can be used to determine these charges and